Hello guys, welcome to my channel Civology, the study of civil engineering. Today in this video we are going to learn how to find invert levels. And in this video we will also learn how to find slope or levels at mid intervals of the pipes and how many pipes will be required, that is how much length of pipes will be required for a specific distance. Okay, so this video is going to be very important. You are all requested, please watch complete video for better understanding of the topic, and if you are new to my channel, please subscribe it and press the bell icon to get video updates. So let's start our today's topic. So let's assume that we have two segments of pipes, the length of which is too long, so that we will have to provide manholes between these two segments of the pipelines. Let's assume that we provide this is the starting point, or you can say the first point of the, or you can say the first manhole. This is the second manhole, and then there is third manhole, and the center to center distance of these manholes are given as 70 feet. Okay, and this is manhole number 1, this is manhole number 2, and this is manhole number 3, and invert level of manhole is given to us, which is 506.99. okay, and first of all we will find the pipe lengths and RDs. As you can see over here, the distance given to us is from center to center of the manhole, but the length of pipe is not given, so we will have to calculate the length of the pipes and RDs. Assume that this is the start point of your project or start point of your sewer line. Okay, so this is 0 0, the reduced distance is 0 0, and the center of the next manhole will be equal to 70 feet, as the center to center distance of manholes is given as 70 feet. The distance of third manhole is given as 140 feet, so the RD over here is 140 feet. As we know that the dia of manhole is given as 2.5 feet, and as you can see over here, this is the diameter of the manhole, so the radius will be equal to 1.25 feet. Okay, so this is the radius. Okay, this is the radius. So RD at point 1, what will be the reduced distance at this point? By point 1 means where the first segment ends and where it enters into manhole number 2. So what will be the reduced distance at this point? This is necessary to find the pipe length, because we will have to calculate the number of pipes. Okay, so it is very important to learn the length of the pipe and the reduced distances at the start and end of the manholes. Okay, so what will be the RD over here? So it will be equal to 70 minus 1.25, as the total distance is 70 from the center of this manhole to the center of this manhole, and the radius is 1. So this distance will be deducted, 1.25 distance will be deducted. We will get the RD of this point, which is 68.75. Similarly, we can calculate the RD at point 2. What will be the reduced distance at this point? This is the start of the second segment of the pipelines, so it will be equal to, as the RD is 70 over here, if we add this 1.25 in this 70 distance, we will get the RD at this distance, which is 71.25. okay, I hope you are getting my point. So now what will be the pipe length? Pipe length will be equal to 70 feet. If you look over here, the total length is 70 feet, and if we subtract this 1.25 and this 1.25, we will get the center of the pipes, or you can say the center length of the pipes between two manholes, which comes out to be 67.5 feet. Okay, so if we talk about the second segment, what will be the end RD, or you can say the RD at point number 3? It will be equal to 71.25, as we have reached over here and the distance is 71.25. if we add 67.5 in it, it will be equal to 138.75. So at the start of the third manhole, the reduced distance is the distance which is taken from some reference point. As the reference point is over here, which is 0.00, so the distance, or you can say the length of the pipe, when it reaches the third manhole, it will be equal to 138.75. So that's how you can calculate the pipe length if the diameter of the manhole is known to us. Okay, so let's proceed to the next step. So the next point is to find the invert levels. Invert level is the level at which water enters into the pipe without any obstruction or without any resistance. Okay, so we'll have to find the invert levels of these manholes. As over here, the invert level of first manhole is given, which is 506.99. okay, so what will be the invert level of second manhole and invert level of third manhole? So for this you will need to know the slope given. This slope is usually given in the drawings of the drainage and sewerage system. Over here, let's suppose we assume the slope which is 0.0045 and its direction is rightward. Okay, the flow should be in right direction. So the arrows shows the direction and 0.0045 is the slope. Okay, so how can you calculate the invert level of manhole number 2 if the invert level of manhole number 1 is given? It's very simple, guys. So as you can see over here, this is the invert level. Okay, this is the invert level of the manhole. This is the lean concrete over which you will have to lay the pipes. Okay, so this is very important to learn. It is very simple. If you know the invert level of first manhole, which is 506.99, simply subtract the product of slope and distance. As you can see over here, the slope is 0.0045 and the distance is 67.5. okay, you will get 506.68. okay, so this is the invert level of the second manhole, and invert level at 2 will be same. This is the invert level at this distance. Okay, this is the invert level of this pipe. As you can see over here, as you in this picture, this is the invert level of this pipe. Okay, similarly, the the, the second segment is starting over here, starting from here, it will be on the same level as the lean provided is on the same level, so the pipe starts and ends from here will have the same invert level. So at point 2 the invert level will be same, which is 506.68. okay, as a whole the invert level of the base of the manhole will be 506.68. now let's find the invert level at point number 3, or you can say let's find the invert level of this manhole. okay, invert level at 3 will be equal to 506.68. as we have calculated the invert level of this manhole, which is 506.68. now we are proceeding rightward. okay, we are going in the rightward direction, and we have calculated the invert level up to point number 2, and now we are proceeding and traveling the distance of 67.5 feet to reach this point number 3. okay, so the distance traveled is 67.5 and the slope is 0.005, and the invert level of previous, or the manhole number 2, is 506.68. so applying this formula we will get the invert level of third manhole, which is 506.37. okay, so actually these are the invert levels of bottom of the pipelines. okay, invert levels of bottoms, or you can say the invert levels of manholes. But the problem arises, as now we have calculated the invert level of manhole number 2 and invert level of manhole number 3. But the problem arises, you will have to, when you lay down the pipes, as you can see over here, when you are laying down the pipes, you will need to calculate the distance levels at random distances For example, if the length of a pipe is 8 feet, so you will have to calculate the levels at every 8 feet, and that level will be read on the top of the pipes. Okay, because you cannot read the levels beneath the pipes or inside the pipes, you will have to place the staff rod on top of the pipes. Okay, so let me tell you how can you find the levels at random distances. Let's suppose we have to find the invert level of this pipe at 8 feet. Okay, which will be the bottom. First we will calculate the bottom levels, then I will tell you how can you calculate the top level of the pipe. Okay, let's suppose we are calculating at 8 feet. Same formula will be applied as we are proceeding from this direction towards right direction, as the slope is rightward. Okay, so as over here the invert level is 506.99, and at 8 feet from manhole number 1, the slope will be 0.0045 multiplied by distance. That is how much distance you are traveling in the direction of the slope. Simply subtract this product, as you can see over here in the bracket. You will subtract this product from the previous non-level, which is 506.99, and it will come out 506.945. This is the bottom level of the pipe at 8 feet. Similarly, if you want to calculate at 32 feet, the same formula will be applied, that is 50. Now the distance is 32 feet from manhole number 1, and the level of the manhole is 506.99. Simply subtract this product, that is slope multiplied by distance. You will get the level at 32 feet, which is 506.846. Similarly, you can calculate for the number of distances as you want to. Okay, so this is the simple formula. This is the product of slope and distance and should be subtracted from the previous known level. I hope you are getting my point. Now, as I told you before, you will have to read the levels, or you will have to place the staff rod on the top of the pipes so that you can adjust the alignment and levels of the pipe, as you cannot place the staff rod inside or beneath the pipe. Okay, so you will have to find the top levels of the pipes. It's very simple, as the distance we have calculated at 8 feet, which is 506.954. So at 8 feet distance, pipe type top level will be equal to 506.954 plus 1 feet. Now this 1 feet is the diameter of the pipe. This 1 feet is diameter of the pipe, plus this thickness of the pipe should be added. If the thickness of the pipe is 1 inches, it will be equal to 0.083 feet, and you will get the top level of the pipe at 8 feet distance. Simply you will have to add this factor, which is the diameter of the pipe and thickness of the RCC pipe. Okay, you can calculate the number the levels at any random distances. Okay, so now coming towards how can you calculate the number of pipes required. It's very simple. Again, let's say length of a pipe is 8 feet. The length of a single pipe, if the length of this pipe is 8 feet, okay, and the distance to be calculated, or the distance to be covered by the pipe is 67.5, as we have calculated in the previous steps. It is 67.5. Simply divide this distance by standard length, which is 8 feet. You will get the number of pipes, 8.43. okay, if you can say it is 8.5 feet. Okay, so this distance can be adjusted in the manhole. It can be shorter or longer to adjust the lengths between 2 segments or 3 segments, or whatever, how much segments you are having. So these are some basic points by following which you can find the levels at any distances. You can find invert levels at any positions. So this is the simple method. I hope you have understand the whole topic. For new videos, you are requested to please subscribe the channel and don't forget to press the bell icon to get video updates. That's all for today.